Okay, my video cut off a second ago, but what I was going over was my strategy pattern for my flea spawner. So, even when the flea spawner is inactive for the wave, when you destroy a mushroom, you ping the flea spawner and say, hey, should I spawn a flea? And that's where the strategy pattern comes in, where my spawn flea check, which is set either to active or inactive, calls the check spawn flea. And if you're inactive, it just does nothing. So it doesn't matter. But if it is active, then it checks if the mushroom count is less than the threshold, and then you go ahead and spawn a flea. So yeah, that was kind of the last thing I wanted to talk about for strategy. For the observer pattern, mine I don't think is as organized as perhaps it should, with the register, remove, notify, callback names per se, but I definitely have that pointer conversation back and forth. So I'll talk about it with the blaster and the bullet really quick. So with the blaster, what I did is that the blaster, there's only ever one instance of the blaster at a time. So the blaster factory creates a blaster. There's a blaster pool, but there's only ever one thing in it. So I have the blaster instance that is just, the only blaster instance for the game, and that's why I can have this function from the blaster factory called getBlaster that returns the blaster instance. So what happens, back in the game manager, when I create... for the entity manager, I go ahead and create the entities, and then I create the blaster spawner. In my blaster spawner is where I create the blaster, and then I give the bullet factory a pointer to this blaster right at the beginning of the game. So I get the blaster from the blaster factory, and I set in the bullet factory a pointer to that reference. So in the bullet factory, I just have this blaster pointer. That's set right from the beginning of the game because it's the the one blaster that I have in the game. And sorry, I was just checking that my mic is picking up. And then every time I create a bullet, so let's go to the bullet factory. Every time I create a bullet, I give that bullet a reference to the blaster. So I'm just passing that blaster instance to it. And then in the bullet, when I am destroyed, bullet destroy, or you deregister the collision here, but what happens is when you collide with anything. So if you collide a mushroom, you say, hey blaster, you can fire again. If you collide with a scorpion, hey blaster, you can fire again. So that's kind of the conversation that's going back to the bullet. And then to the blaster. And then in the blaster, fire, that's where it references the fire. So it checks if I can fire, then we set it to false and we create the bullet, and then the bullet has a pointer back to this blaster, so then it can set it back to true when the bullet collides with something. So that's kind of an example of the observer pattern. Another example that we went over with the observer pattern was the mushroom having to talk to the grid manager. So I wanted to go over that really quick as well. And I actually wanted to kind of talk about, I'll do that in a bit. Let me just say the observer pattern with the mushroom. So in the mushroom factory, when you create a mushroom, create mushroom, the mushroom factory has a pointer to the grid manager. So basically the grid manager has a 2D array of mushroom pointers, and that represents the current mushroom field. So that's the thing that each mushroom needs to interact with when it gets destroyed. So that's kind of where I'm going. So the mushroom factory is given, there's this function called setGridManager, and it is given a pointer to the grid manager right at the beginning of the game as well. So it gives that pointer to that grid manager to every mushroom that it creates. You can see in the mushroom initialize function, right at the end here, it gives a pointer to the grid manager. So if we go down to the mushroom, in the initialize grid manager, you see that that is initialized. And then let's say that the mushroom gets hit with a bullet and needs to be destroyed. So right here is when the bullet is killed. So I ping the grid manager that I have this pointer to, and I say, hey, remove me from the mushroom field. So if we go there, you can see that, I'll go over this in a second, but we do the flea spawner thing, and then we set that to null. And then back in the mushroom, we mark ourselves for destroy. So that is how each mushroom communicates with the grid manager that it has been destroyed through that pointer communication, which is the observer pattern. Okay, so next on the list is factories. I have factories for everything except mushroom regen, which is a game object that happens, but everything else has a factory. I guess let me just pick another one to prove it. If you go to critter factories, and let's just pick the spider factory for fun. So the factories are singletons, like we talked about, but they each have an object pool. So here is the spider object pool, which has the list of recycled items. It has the get spider and the return spider methods. So when you get a spider, you see if there's anything in the recycled. If there isn't, you have to create a new one. But if there is, then you just pop that, or get the top, pop it off, and register it to the scene. Returning the spider is you just push it to that recycled items stack. So in the spider factory, when someone says, "Hey, I need a new spider," you get it from the object pool. Go over that in a second, and then you initialize it, and you set the external management to recycle spider. So in terms of the active spiders, you do need to keep track of the active spiders on the screen so that during, if the player dies, you can freeze all of them and then you can destroy them. So in my factory, I have a vector full of active spiders. I think other places I actually have a list, but list vector, whatever, of spider pointers. So when you create one, you push that spider back into the active spider list. Then when you recycle it, you have to erase that specific, so S is the game object. So you're going to erase that from the vector, so that, if you happen to just, shoot a spider in the middle of the wave, you want to make sure that that is removed from the active spider list. Right here, it has to do with the sound. If you only want to send the crawl sound to the manager if the list is empty, right? Like if somehow you had 3 spiders on screen at a time, you don't want the sound to be played over and over. You just want to send it if there's nothing else on there. So that's what this check is. And this is the same thing with the sound crawl stop, which I'll go over later because that has to do with the sound manager. But just to point that out, that you do keep track of the active spiders, and every one of the factories has a similar component. So I have, a vector which keeps track of the active fleas, which works similarly, and all of the critters have those corresponding things. I guess something that is relevant there is that when we have the loss of life callback, so that's when the mushroom regeneration happens, right? When you run into a critter and you die, and the mushroom regeneration happens. So I wanted to have the effect where all of the critters on the screen freeze, which you saw earlier. So what you do is you go to My Entity Manager, freeze all entities, and then you go through each of the spawners and freeze all spiders. So for instance, if we go to Scorpion, freeze all scorpions. The reason I went through the spawners is because the game entity manager, I didn't want to have to include all of the factories here, since the spawners, since the entity manager creates all the spawners and has references to them, I could just go through the spawners to get to the factories. So if I go to scorpion spawner, freeze all scorpions, all that does is for every spider, or for every scorpion in the active scorpion list, which is right here, I just freeze them. And the freeze, once again, uses a strategy pattern. I have the different move modes for the critters, and it sets it to frozen move mode. So just for fun to go look at this really quick, critter move mode is once again another strategy pattern. All of the critters are derived, you know, they're children of this critter, you know, up at the top. And that way I could use the same move modes for all of them. So I have the active move mode and then frozen move mode. So each of these, the scorpion, for instance, all that it does in its update is call that move mode and say, hey, move update, am I moving or am I not? Most of the time you're moving, but if you happen to be in the middle of a mushroom regen, you'll be in that frozen mode. And all of the critters use that same strategy pattern. So they do the move mode, move update. So right, when you freeze them right here, you just set the move mode to the frozen move mode. And the spawners have the references to those, I believe. Trying to think where those happen. Right, so we have get active move mode or get frozen move mode. For those are stored in the spawners, and then the each individual critter will set its move mode, you know, if it's based on whether it's frozen or not. So anyway, that was kind of a long detour from factories, but I went over the factory and the active critters, like the vector that each of those factories has to keep track of them. And right now I think I just want to go over the singleton really quickly, because all of my factories, like I said, my only singletons are the game manager and then the factories. So let's just pick a factory. What else? My explosions are factories. Let me try to find them. So, just using this one for instance. Well, I'll talk about explosions later. So singleton. We have everything is private up here. We have the pointer instance, which is a static variable. You can't reference any of this stuff. It's private. All of these are the private methods, non-static methods. These are private variables. Right, and then we have the public methods, which just call, you know, the instance with the private method. And no static classes, properly destroyed. So, right, you know, each one of these, you know, if we create a private one cell explosion, it just does what it does. We have the pointer instance set to null at the you know, it has to be defined at the beginning since it's static. Instance has, you know, if there's nothing there, create a new one, return the pointer instance. And for terminate, we delete the pointer instance and set it to null. For every single one of my factories, I call terminate at the game end. So as you can see here, I include all of the factories and I terminate all of them at the end, and to make sure everything gets cleaned up correctly. And, you know, for all of the spiders or the you know, all the critters in the destructors of the object pools, all of the recycled items get deleted. You know, for instance, in the mushroom object pool, in the destructor, everything gets deleted there. So it's cleaned up nicely. And I think that covers the singleton. I guess just to prove that my game manager is a singleton as well, I can show it. You know, we have pointer instance and the instance. All of this is private. Here are the only public methods. All of this stuff is private. And here are the, you know, methods called, you know, pass through, for the ones you can call externally. And in the game manager as well, I have I set the pointer instance to null. I have the instance method, and at the bottom I have the end and everything. So I guess I don't have a terminate, which I'm a bit confused by. Somehow it gets cleaned up. Oh, because it's a game object, right? Since it's a game object, I think it cleans itself up. Teal cleans it up. There's not a leak for it, so that's, I guess, what I'm assuming happens. Right, so that is the end of my singleton talk, factory talk, observer pattern and strategy pattern. I'm gonna stop this video and then go on to the command pattern and other stuff next.